scientists were trying to develop an airplane that would satisfy the needs of the Navy and the needs of the Air Force, Marines, or anybody else. Let's get an airplane that can do the mission for both. It'll be a lot cheaper. Robert McNamara, cost effectiveness. We got to do it. Well, the problem was that technology had not gotten to the stage where you could really do that. McNamara, he mandated that we would have a single aircraft. He even got so far as to overrule the military and pick the contractor, which was General Dynamics. The problem was it was at least a 50,000-pound airplane. And in order to be a performing fighter, it had to have about 50,000 pounds of thrust, which meant you had to have two engines with 25,000 pounds apiece, or it really wasn't going to be a very good fighter. And we didn't have an engine that we knew about that would give us 25,000 pounds of thrust. They happened to have one in a thing called the SR-71, which was a special airplane with special fuel and everything. But for the conventional, no way. And then McNamara made it more difficult by saying, hey, listen, they were having trouble with the weight. So he says, okay, you can go to 55,000 pounds. When he went to 55,000 pounds, that airplane was essentially dead for the Navy, because there was no way we could keep it, really make it a stable, workable platform that would land aboard an aircraft carrier safely, the way we needed to do it. We built 8 versions of the bird for the Navy, put tailhooks on it, took it out, scrambled around, but it was awful. It was a disaster. And who was one of the key guys involved in that program? Our old friend Dick Ashworth of VC-6 fame. He was now a key guy in the process. It ended up being a can of worms. McNamara said, oh. Ashworth went over to NATO, Europe for a while, eventually commanded the 6th Fleet, but wonderful guy, bit the dust because of that. How did we kill that F-111 aircraft? Well, we got in front of this committee, our Senate Armed Services Committee, and we testified, and the Navy is saying, this bird is not for us. We don't want it, we don't need it, so forth. I could be a key witness on this. I had 2 luncheons with the Secretary of the Navy. He called me in personally. This is Paul Nitz, a wonderful guy, terrific guy. Called me in luncheon, just one-on-one. You know, Jerry, we want you to go over and testify in favor of this airplane. Mr. Secretary, if I go over there, I will not only testify that it's a dog from a point of view of performance, but I will say we don't need that kind of an airplane. We need a fighter. This thing is a great big monstrous interceptor for shooting down masses of incoming Soviet bombers, but we don't need it for the Navy. It's not our bird. That's what I'll say. Well, you're not going to send me over there and put me in front of a committee to say that. So, 2 or 3 weeks later, we have another luncheon. Same thing, same results. Well, they did have the hearings. The Senate Armed Services Committee knew exactly what was wrong there, that this was a real dog. And it was not to be had. The taxpayers shouldn't waste money on it. But McNamara is pushing it. He's got a new Secretary of the Navy named Paul Ignatius. He's got an Assistant Secretary of the Navy for Research and Development. And they go over as the witnesses, and they take 2 military officers with them. One is the Chief of Naval Operations, newly assigned, named Admiral Tom Moore, who is really first class, very, very well respected. And we have a smart, really smart backup guy, head of naval aviation, a guy named Thomas Francis Conley, class of 1933 at the U.S. Naval Academy, rope climber, bronze star in the 32 Olympics for rope climbing. I mean, this was a sport back in those days. The hearings start. Only people present are Stennis, who was the chairman, and his chief of staff, a guy named Ben Gallay. When you have a hearing in front of the Congress, you've got to have it in the record if you're going to take any action. So the senator starts asking questions. And the Secretary Ignatius, he is pushing the McNamara position. We need the airplane, this is it. Admiral Moore was a brand new Chief of Naval Operations, and he was kind of in a spot. We knew, in the operating level, we knew that Moore wanted this airplane killed. But we would never say that because that would put him on the spot. But we knew that he wanted it killed. Any aviator that was faced with the idea of using this thing or flying it would not want to have it in the Navy. Thomas Francis Conley, he'd actually flown. I actually flew the Air Force version of the airplane a couple of flights, and Conley had flown it too. Wonderful bird, had some great capabilities for a land-based bomber, but not for a Navy fighter off an aircraft carrier. With the hearings are going along, we're getting nowhere. Finally, I'm sitting in the back of the back hall, back of the room. Gallet motions to me, go outside. He says, the chairman is not getting what he needs. He's got to have some positive evidence on the record that this thing is a dog and we couldn't have it. What are we going to do about it? I said, okay, get me a secretary here. Secretary comes over, I says, here's a question for the senator to ask of Admiral Conley. Conley had not yet said a word. And Admiral Conley, we know about your reputation in naval aviation, that you're a great authority, this and that and the other thing, and he stole his virtues. What do you think, Admiral Conley? Give me your personal opinion. What do you think about this bird? And Gallet took it in, gave it to the senator. The senator looked at it. I came back in the room, and pretty soon the senator, he had a wonderful technique, terrific guy. He led up to it a little bit, and he finally turned to Admiral Conley. He says, Admiral Conley, I haven't heard anything from you. He says, what do you think about this bird? He says, we know about your reputation, so forth and so on. And Conley was on the spot. He knew he was on the spot. Conley wanted to be a 4-star officer. He had everything going for him. But now here was a question from the Senate, chairman of the Senate Armed Services Committee, saying, what do you think about this bird? And I still remember, I'm sitting right there behind him. He swallows once and says, leans forward and says, Mr. Chairman, there is not enough thrust in all Christendom to fix that airplane. 5 minutes later, the hearings were over. That was the end of the F-111B, the Navy version of the TFX aircraft. That was the way it died. It took me a year before I had the guts to tell Conley I'd set him up. But of course, that was the end of his, no chance for a 4-star for him. It was a sensitive period. But these are the kinds of things that you have to do once in a while if you're going to be a servant of the taxpayers, if you're going to serve your country. Every once in a while, if you're a doer in this business, you better damn well do the right thing when the position is put in front of you. And Conley did the right thing. It cost him the rest of his career, but it saved the taxpayers from having a real dog of an airplane, which has turned out to be. That was the beginning of the F-14. I've made a speech one time. I flew the F-14 just before I retired. I determined that Naval Academy graduates from the class of 1942 through the class of 02, 60 years, had flown that F-14 aircraft. It was that good. Now we get to the F-35. Technology in the 70s could not give us, 60s, could not give us an airplane that would satisfy the missions of both. It just wouldn't do it. But now we come 30, 40 years later, Lockheed comes up with a wonderful design. Technology's moved a lot forward. We can have an engine that can give us great thrust. We can get commonality in many of the spare parts. We can have an airplane that will be almost identical to the Navy, the Marine Corps, the Air Force. Not only for the United States, but it can be a great international aircraft. It can be terrific for the Brits. If they want to have small aircraft carriers, use the Marine Corps version of the F-35. If it's the Italians, the Norwegians, the Australians, the Canadians, they all signed on board. This was a wonderful, wonderful idea for marketing. The United States got smart. Britain, you want to have a role in this? Come up with $1 billion And that'll give you an opportunity to compete in the production of the aircraft. Then we get around to whether, is the thing any good? Is it really going to work? Well, you take a look at it, and you study the three different versions, Air Force, Navy, and Marine Corps. You take a look at it, it's fascinating, absolutely fascinating. What they call the B version is the one that'll be vertical, take off and replace the British Harrier. You take the tailpipe and you turn it down. Russian design, Russian design. But the unique thing about that one is, in the Harrier, it's unstable. You got a little air coming off from underneath the wing, and you got the engine's thrust going down, but that's what it's riding on. With the F-35, very smart. They took the jet engine that's driving the thing, and they put a spindle on the front of it, and they make it drive a fan. It becomes a lift engine, a lift fan. They open up the top of the fuselage, the air comes down, comes out the bottom. You got a lift fan. You got the engine making thrust out the rear end. You got the lift fan in the front giving the stability there. Now, instead of like in the Harrier with 3 points of stability of lift, you got 4. And furthermore, that air is cool, and it cools the ground underneath, therefore eliminates the hot deck. It really makes a cushion, and it's a wonderful idea, terrific. The Air Force version, which was much the same from a point of view, an airframe point of view, a little smaller, but not many changes. The Navy version, a little bigger because it's going to operate off the carrier, it's a little more stress. But then when you go down to the production line and see what they were able to do, what they've been able to do in the production line and improving techniques, talk to the test pilots who flew the prototypes. It's unbelievable, the kinds of things that are going on. So the whole airplane, the whole concept, is a major mover forward in technology, and there seems to be every possibility of it producing and delivering, not only for the Army, Navy, and Air Force of the United States, but for the Canadians and a lot of the other ones, the free world.
The F-35 Lightning II is one of America's most iconic fighter aircraft. Only a close second to the feared F-22 Raptor. Its visionary innovations have been both bane and blessing. The plane's design has received admiration and appreciation globally. It stood as a reminder that American engineering and ingenuity could achieve the seemingly impossible, while ushering in a new age of military aeronautics. The F-35's story begins with the Joint Strike Fighter program, which aimed to create a new generation of STOVL aircraft that could replace the landmark F-16. The nation's industry titans competed for access to the resulting contract. McDonnell Douglas, Northrop Grumman, Boeing, and Lockheed Martin worked tirelessly to present their most innovative designs as offerings. However, Lockheed's revolutionary, reheated turbofan-augmented thrust engine, with its futuristic lift system, would win the coveted opportunity. While Boeing's design certainly came with less challenges than Lockheed's, the Department of Defense determined that Lockheed's pioneering lift fan system's superior performance far outweighed its risks. And so, the historic company would join the US government on a journey to permanently change the standards and capabilities of the modern jet fighter. The backbone of the F-35 program would be its unprecedented Pratt & Whitney F-135 engine. The company would join teams with Rolls-Royce and Hamilton-Sundstrand to create a revolutionary propulsion system that allowed for shatteringly short takeoff times. Rolls-Royce would develop the lift system, which was conceived using seminal new technology. Unlike the Yak-38, which used separate lift engines or the rotating nozzles of the Harrier, the new engine used a highly flexible, thrust-vectoring nozzle that could provide the needed lift. The F-135's nozzle was also capable of withstanding afterburn temperatures. The nozzle would direct thrust in any direction the pilot needed to carry out a wide range of landing and takeoff capabilities, while maintaining significant stealth. In order to achieve vertical flight, the propulsion system equipped a whopping 29,000 horsepower. To this day, the technology, ingenuity, and genius that went into designing the F-135 is considered one of, if not the greatest feat in the aeronautical history of America, for which it won the esteemed Collier Trophy. It was billed as a fighter jet that could do almost everything the U.S. military desired, serving the Air Force, Marine Corps, and Navy, and even Britain's Royal Air Force and Royal Navy, all in one aircraft design. It's supposed to replace and improve upon several current and aging aircraft types, with widely different missions. It's marketed as a cost-effective, powerful multirole fighter airplane, significantly better than anything potential adversaries could build in the next 2 decades. Lockheed Martin said the plane would be far better than current aircraft, quote, 4 times more effective in air-to-air combat and 8 times more effective in air-to-ground combat. Not only that, but also 3 times more effective in recognizing and suppressing an enemy's air defenses. It would, in fact, be second only to the F-22 in air superiority. In addition, the F-35 was to have better range and require less logistics support than current military aircraft. The Pentagon is still calling the F-35, quote, the most affordable, lethal, supportable, and survivable aircraft ever to be used. Like the F-117 and F-22, the F-35's stealth capability greatly reduces but does not eliminate its radar cross-section, the signal that radar receivers see bouncing back off an airplane. The plane looks smaller on radar, perhaps like a bird rather than a plane, but is not invisible. The F-35 is designed to be stealthy primarily in the X-band, the radar frequency range most commonly used for targeting in air-to-air combat. Of course, radar is not the only way to locate and target an aircraft. One can also use an aircraft's infrared emissions, which are created by friction-generated heat as it flies through the air along with its hot engines. Several nations, particularly the Russians, have excellent passive infrared search and tracking systems that can locate and target enemy aircraft with great precision, sometimes using lasers to measure exact distances, but without needing radar. It is also very common in air-to-air battles for opposing planes to come close enough that their pilots can see each other. Lockheed Martin and the Pentagon say the F-35's superiority over its rivals lies in its ability to remain undetected, giving it, quote, first look, first shot, first kill. The F-35 program is the result of the merging or combination of several other separate and diverse projects into a set of requirements for an airplane that is trying to be everything to everybody. In combat, the difference between winning and losing is often not very great, with second place all too often meaning death. The Pentagon seeks to provide warriors with the best possible equipment. The best tools are those that are tailor-made to address specific missions and types of combat. For a fighter airplane, funding decisions become a balancing act of procuring not just the best aircraft possible, but enough of them to make an effective force. This has led to the creation of so-called multirole fighter aircraft, capable both in air-to-air combat and against ground targets. Where trade-offs have to happen, designers of most multirole fighters emphasize aerial combat strength, reducing air-to-ground capabilities. The F-35 is an excellent piece of equipment, despite its shortcomings. Fourth-generation fighters hailing from 3 nations, including F-16 Fighting Falcons, F-15 Eagles, and Eurofighter Typhoons, coordinated with E-8 Joint STARS Command. As their stealthy escorts, both F-22 Raptors and F-35 Joint Strike Fighters surveyed the battle space. Soon, cockpit displays in each aircraft began to light up and alarms sounded, indicating that the formation was being painted by multiple radar arrays tied to surface-to-air missiles and inbound fighters. Enemy fighters sporting the color schemes of Russian Su-30s began to close in. Trevolis Simmons, commander of the 57th Adversary Tactics Group, noted that on the last week of a red flag exercise, we really throw everything we have at the Blue Force and replicate the toughest adversary possible. Ultimately, the F-35 fighter jet won the day, breaking down one of the world's most advanced air defense networks and relaying the data to missile-packed fighters like the F-16. The F-35 can fly at speeds as high as Mach 1.6 and can carry an internal payload of 4 weapons without compromising its stealth. But it's not the F-35's firepower that really makes the difference. It's the computing power. It's why F-35s have come to be known as quarterbacks in the sky, or a computer that happens to fly. Major Justin Hazardley, an Air Force F-35 pilot instructor, noted that, quote, "There has never been an aircraft that provides as much situational awareness as the F-35. In combat situational awareness, the F-35 is worth its weight in gold." The aircraft we know today as the F-35 was built to meet the demands of multiple fighting forces with a single, highly capable aircraft. This new Joint Strike Fighter, Pentagon officials believed, would allow for streamlined logistical supply lines, maintenance, and training. It would also leverage the same stealth technologies found in the F-22. With a laundry list of requirements from the US Navy, Air Force, DARPA, and soon the UK and Canada, the Joint Strike Fighter program quickly moved from its official proposal in 1995 to 2 competitive prototypes in 1997. Lockheed Martin's X-35 and Boeing's X-32. And the new fighter had its work cut out for it. The Joint Strike Fighter needed to replace at least 5 different aircraft across all the different services, including the high-speed interceptor F-14 Tomcat and the tank-killing close air support A-10 Thunderbolt II. Designed from the ground up to prioritize low observability, the F-35 may be the stealthiest fighter in operation today. It uses a single F-135 engine that produces 40,000 pounds of thrust, with the afterburner engaged, capable of pushing the sleek but husky fighter to speeds as high as Mach 1.6. The aircraft can carry 4 weapons internally while flying in contested airspace, or can be outfitted with 6 additional weapons mounted on external hardpoints when flying in low-risk environments. The F-35A also comes equipped with an internal 4-barrel, 25mm rotary cannon hidden behind a small door to minimize radar returns, allowing the F-35 to engage both airborne and ground-based targets. Lockheed Martin has developed a new internal weapons carriage that will eventually allow it to carry an additional 2 missiles internally. The cockpit of the F-35 foregoes the litany of gauges and screens found in previous generations of fighter, in favor of large touchscreens and a helmet-mounted display system that allows the pilot to see real-time information. This helmet also allows the pilot to look directly through the aircraft, thanks to the F-35's Distributed Aperture System, also known as DAS. and a suite of 6 infrared cameras mounted strategically around the aircraft. In an interview with the New York Times, Tom Burbidge, Lockheed's general manager of the program from 2000 to 2013, said that, quote, "If you were to go back to the year 2000 and somebody said, I can build an airplane that is stealthy and has vertical takeoff and landing capabilities and can go supersonic, most people in the industry would have said, that's impossible. The technology to bring all of that together into a single platform was beyond the reach of industry at that time." While both the X-32 and X-35 prototypes performed well, the deciding factor in the competition may have been the F-35's complicated short takeoff and vertical landing flight. Because the US Marine Corps intended to use this new plane as a replacement for the AV-8B Harrier jump jets, America's new stealth fighter had to be able to fill the same vertical landing short takeoff role. The lift fan design used in the X-35 connected the engine at the back of the aircraft to a drive shaft that would power a large fan installed in the aircraft's fuselage behind the pilot. When hovering, the F-35 would orient its engine downward, not unlike the X-32, but it would also pull air from above the aircraft and force it down through the fan and out the bottom, creating 2 balanced sources of thrust that made the aircraft far more stable. It also helped the F-35 notch a win in the looks category. Rick Resbeck, an engineer at Lockheed, said, quote, "You can look at the Lockheed Martin airplane and say, that looks like what I would expect a modern, high-performance, high-capable jet fighter to look like. You look at the Boeing airplane, and the general reaction is, I don't get it." Ultimately, Lockheed Martin won out over Boeing's unusual-looking X-32 prototype in October of 2001. The future looked bright for the newly named F-35. While Lockheed's lift fan approach to STOVL flight might have nabbed the contract, the hard part was just beginning. Choosing to begin with the least complex iteration of the new fighter, Lockheed's Skunk Works started designing the F-35A, intended for use in the US Air Force as a traditional runway fighter, like the F-16 Fighting Falcon. Once the F-35A was complete, the engineering team would then move on to more complex STOVL F-35B for use by the US Marine Corps, and then finally the F-35C, meant for carrier duty. There was just one problem. Jamming all the necessary hardware for the different variants into a single fuselage proved extremely difficult. By the time Lockheed Martin wrapped up design work on the F-35A and got to work on the B, they realized the weight estimates they had established while designing the Air Force variant would lead to an aircraft that was 3,000 pounds too heavy. This miscalculation created a significant setback. To truly understand the F-35, you have to understand its variants and their differing capabilities. The F-35A is intended for use by the US Air Force and many allied nations. The F-35A is the conventional takeoff and landing CTOL variant. This aircraft is intended to operate out of traditional airstrips, and is the only version of the F-35 to come equipped with a 25mm internal cannon, allowing it to step in for both the F-16 multirole fighter and the Flying Cannon A-10 Thunderbolt II, among many others. The F-35B was purpose-built for short takeoff and vertical landing operations, or STOVL, and was designed with the needs of the US Marine Corps in mind. While still able to operate off of traditional runways, the STOVL capability offered by the F-35B allows Marines to operate these jets from austere runways, or off the decks of amphibious assault ships, often referred to as Lightning carriers. And finally, the F-35C is the first stealth fighter ever designed for carrier operations with the US Navy. It boasts larger wings than its peers, to allow for slower approach speeds when landing on a carrier. More robust landing gear aids in tough carrier landings, and it harbors a larger fuel supply, roughly 20,000 pounds worth, internally, to support longer range missions. The C is also the only F-35 equipped with the folding wings, allowing for easier storage in the hull of ships. Lockheed Martin's team would eventually work out the finer points of each different platform. So what really separates the pricey F-35 from the fighter jets that have come before it? 2 words: data management. Today's pilots have to manage a huge amount of information while flying, and doing so means splitting your time between traveling the speed of sound and a collage of screens, gauges, and sensor readouts screaming for your attention. Unlike previous fighter jets, the F-35 uses a combination of heads-up display and helmet-based augmented reality to keep vital information directly in the pilot's field of view. Some of the plane's helmet's features include every Generation 3 being customized to its owner's head to prevent slippage during flight and to ensure that the displays appear in correct locations. To do this, technicians scan each pilot's head, mapping every feature and translating it into the helmet's inner lining. Pilots used to have to switch over to a mounted night vision attachment when flying in the dark. The Generation 3 helmet projects a night vision reading of the surrounding environment directly onto the visor when the pilot switches the system on. The shell is made of carbon fiber, which is what gives it its characteristic checkered pattern. A tight coil of bound cables comes out of the back of the helmet to connect it to the plane. When the wearer turns his head in a specific direction, the wires feed the helmet the proper camera footage. The communication system has active noise cancellation. Speakers produce a sound that opposes wind noise and the low-frequency hum of the jet engines so pilots can hear clearly. The F-35 fuses everything into a green dot if you are looking at a good guy, and a red dot if it's a bad guy. It's very pilot-friendly. All the information is shown on a panoramic cockpit display that is essentially 2 giant iPads. It's not just how the information reaches the pilot, but also how it's collected. The F-35 is capable of gathering information from a wide variety of sensors located on the aircraft and from information sourced from ground vehicles, drones, other aircraft, and nearby ships. It collects all of that information, as well as network-driven data about targets and nearby threats, and spits it all out into a single interface the pilot can easily manage while flying. With a god's-eye view of the area, F-35 pilots can coordinate efforts with 4th-generation aircraft, making them deadlier in the process. The F-35 is the quarterback of the battlefield. Its job is to make everyone around it better. 4th-generation fighters like the F-16 and F-15 will be relevant until at least the late 2040s. Because there are so many more of them than the F-35, the job of F-35 pilots is to use their unique assets to shape the battlefield and make it more survivable for other planes. All of that information may sound daunting, but for fighter pilots who've experienced the daunting task of compiling information from a dozen different screens and gauges, the F-35's user interface is nothing short of miraculous. Tony Wilson, who served in the US Navy for 25 years prior to joining Lockheed Martin as a test pilot, has flown over 20 different aircraft, from helicopters to the U-2 spy plane and even a Russian MiG-15. According to him, the F-35 is by far the easiest aircraft to fly that he's come across. He notes that as we move into 4th-generation fighters like the F-16, we moved from being pilots to being sensor managers. Now, with the F-35, sensor fusion allows us to take some of that sensor management responsibility off the pilot's hands, allowing them to be true tacticians. In May of 2018, the Israeli Defense Force became the first nation to send F-35s into combat, conducting 2 airstrikes with the F-35As in the Middle East. By September of the same year, the US Marine Corps sent their first F-35Bs into the fight, engaging ground targets in Afghanistan, followed by the US Air Force using their F-35As for airstrikes in Iraq in April 2019. Today, over 500 F-35 Lightning IIs have been delivered to 9 nations and are operating out of 23 air bases around the world. That's more than Russia's fleet of 5th-generation Su-57s and China's fleet of J-20s combined. With literally thousands more on order, the F-35 promises to be the backbone of U.S. air power. And unlike previous fighter generations, the F-35's capabilities are expected to keep up with the times. Thanks to software architecture designed to allow the F-35 to receive frequent updates, the aircraft's form has stayed the same, but its function has already changed radically. The airplane that took flight in 2006 may have looked identical on the outside, but it was a very different aircraft than the one flying today. And the F-35 flying 10 years from now is going to be very different from the one flying today. The F-35 will also serve as a test bed for technologies that will become commonplace in the next generation of jets. Flying in coordination with AI-enabled drones will become a staple of any 6th-generation fighter, and those new fighter tricks will likely first arrive in the form of the F-35. According to many pilots and experts, it may well be the most capable, most connected, most survivable aircraft on the face of the planet, and what we're able to achieve with it today shows that we can't even imagine what tomorrow's F-35 is going to be capable of. So was the F-35 an obliterating headache or a good omen? Only time will tell if the US government's investment was worthwhile. So far, it seems to be paying off.